Okay, so we have some more limits of exponentials. So just remember, if you're looking for the end behaviors, if they're asking for the limit of infinity or negative infinity, you're going to have to sketch a graph. So for number 3, this 2/3 tells us that it's going to be decay. The negative out front tells us it's going to reflect over the x-axis. But then we do have this negative here, which tells us it's going to reflect, reflect over the y-axis. And then the 3 tells us that we're going to have a horizontal asymptote at 3. Okay, so guys, I'm going to do this a little differently, just in case you don't see this to start out with. You'll be able to do this. So horizontal asymptote at y equals 3. Down there first. Okay, so all the lines are drawn here are dashed lines besides the horizontal asymptote, or just the beginning process. So if I do a decay graph, it would look like this. So check on the decay. Then next you would have to reflect over the y-axis. So see, that's why it really becomes a growth graph when you do that. Then we're going to take that growth graph, and if we reflect it over the x-axis, the graph is going to look like that. Okay, so decay, then it turns into growth when you reflect over the y, then you got to reflect over the x. So this wanted to know the limit as x approaches infinity. So we're looking at the right end behavior, which is here, and that's going towards negative infinity. Alright, for number 4, the negative in front tells us reflect over the x. And then this 2 tells us it's going to be growth. And then this negative up here tells us reflect over y. And then this 2 tells us we have that horizontal asymptote at 2. So if we draw our horizontal asymptote at 2, we start out with growth, but because we reflect over the y, it actually turns out to be a decay graph. And then we got to do the decay, and we have to reflect it over the x-axis. So the graph's going to look like that. So we want to find the limit as x approaches infinity, which is the right end behavior, which is this side, and it's getting closer and closer to that horizontal asymptote 2. Okay, so look at number 5. 5 is another exponential. It does say e. So guys, e is a number, it's like 2.71. So that means it's going to be growth. And we do have this negative here, so it's going to reflect over the y-axis. And this 2 tells us we're going to have a horizontal asymptote at y equals 2. So if we draw our graph, horizontal asymptote at 2. So it starts out as growth. The only thing we're going to do here is reflect over the y's. I drew that wrong. Sorry. Ignore that. So it starts out as growth. Well, we're going to reflect over the y, so it has to become decay. So that will be our graph that we actually look at. Sorry about that. So we're doing the limit as x approaches negative infinity. So that's going to be our left end behavior, which means it's going towards infinity. Alright, and then number 6, the limit as x approaches infinity. This negative out front tells us to reflect over the x-axis. This 0.4 tells us we're going to do decay. And this -4 tells us horizontal asymptote at y equals -4. Okay, so if we draw this, got our horizontal asymptote. We're going to start out as decay. but then we have to reflect over the x-axis, so the graph is going to look like this. We want to find the limit as x approaches infinity, so that's the right side in behavior, and that's going closer and closer to that horizontal asymptote -4. Okay, so on 1 through 6, every limit we've looked at is the limit as x approaches infinity or negative infinity. So for 7 and 8, if you notice, these are the limits as x approaches a number. So when you have x approaches a number, it doesn't matter what the graph. You can use the graph, but since we don't have the graph, the graph's not going to help us a lot here. So we're just doing direct substitution. But I want you to make yourself a note. So this is not in behavior. So use direct substitution if you can. So when you see an exponential, just make sure you pay attention to if it's asking about infinity or negative infinity, or if it's a number. So direct substitution, we're going to plug it in at 3. So we're going to end up with e to the -1 plus 2, or we could write that 1 over e plus 2. Remember, e is a number, so you just leave it in there. And then this is the limit as x approaches -2, so same thing, we can use direct substitution and plug in that -2. So we're going to have 1/2 to the -1 power plus 3. Anything to the negative power just means it's going to flip the fraction, so it's really 2 plus 3, so we're going to get 5. So just make sure you see the difference on when you need to look at the graph, when you're looking at end behavior versus when you can just do your direct substitution.